Let's take a look at the molecular geometry for PO43-, the phosphate ion. We can see from the Lewis structure there are 4 oxygens bonded to that central phosphorus atom. And if we imagine them spreading out as far away from each other as possible, according to valence shell electron pair repulsion theory, we might think of something like we see here on the screen. The problem is this is 2 dimensions, and molecules, they can spread out in 3 dimensions. So let's use the AXN notation to figure out the molecular geometry here for PO43-. A, that's the phosphorus we're talking about. X, that's the number of atoms bonded to the phosphorus. We have 4 oxygens, we'll put a 4 right here. And then N, that's the number of non-bonding electron pairs on the central phosphorus. Well, all of the electrons around that phosphorus are involved in chemical bonds, so we can just forget about N. We could have either memorized that AX4 is tetrahedral, or we could look it up on a table if we're allowed to do that. So we have AX4, we come down our table, AX2, AX3, and here's AX4, and that tells us indeed that we have a tetrahedral molecular geometry for PO43-, and that those bond angles are 109.5 degrees. When we look at that tetrahedral structure in 3 dimensions, here the colors aren't right, but if you imagine the phosphorus is in the center, and then these oxygens are on the outsides of that, the tetrahedral structure will have bond angles of 109.5 degrees. And that's that bond angle there, or over here, along here. Any of those angles will be 109.5 degrees. So that's the molecular geometry or shape for PO43-, the phosphate ion. This is Dr. B, and thanks for watching.